To sustain the wounds it received, the attacking shark must have been very large, possibly 18 or 20 feet in length.
The ocean hides secrets even the strongest predators cannot escape. A great white shark, feared and unmatched, was found missing its most vital organs. Scientists finally discovered the shocking truth of what ate it, and it is terrifying. Could the ocean have a hunter even bigger and smarter than the shark? Join us as we uncover this dark and hidden predator. The apex predator myth. For a very long time, the great white shark ruled the ocean with quiet power. It did not need to roar or show off. Its presence alone changed the sea around it. When a great white appeared, other animals moved away. The water seemed to hold its breath. This shark was not just another hunter. It was the hunter. The great white shark is built for dominance. Its body is large, strong, and shaped like a living weapon. It moves through the water with smooth control, wasting no energy. With a single sweep of its tail, it can surge forward faster than most sea animals can react. Its jaws hold rows of sharp triangle-shaped teeth that are designed to tear through thick skin and bone. When it bites, it does not need to bite twice. Strength alone did not make the great white special. It also had patience. It could rise silently from deep, dark water and strike from below. This surprise attack made seals and sea lions almost helpless. In just seconds, a hunt could be over. Because of this skill, great whites sat at the very top of the marine food web. Nothing hunted them on a regular basis. Nothing chased them away. They were the final stop in the chain of life. For humans, the great white became a symbol of fear and wonder. Stories about it traveled across beaches and boats. Sailors spoke of shadows beneath the waves. Divers felt watched even when they saw nothing. Then movies like Jaws turned the great white into a legend. It became the face of ocean terror. While the film exaggerated reality, it also reflected a real truth. This shark was powerful, efficient, and deeply misunderstood. Scientists also respected the great white. Marine biologists studied it carefully, knowing they were observing one of nature's most successful predators. Research showed that great whites played a key role in keeping ocean life balanced. By hunting the weak or sick, they helped keep prey populations healthy. Remove the great white, and the system could fall apart. Before the year 2020, scientific understanding was clear and steady. Great white sharks had almost no natural enemies. Young sharks could sometimes fall prey to larger sharks, but once grown, they were nearly untouchable. The ocean had many dangers, but for an adult great white, very little posed a serious threat. There were whispers, though. Some researchers suspected that deadly whales might be able to challenge great whites. Orcas were intelligent, social, and strong. They hunted in groups and used strategy. Still, this idea stayed mostly in theory. There was no solid proof, no clear observation, no confirmed evidence. It was a question without an answer. Then came the strange disappearances. In several parts of the world, scientists tagged great white sharks to track their movements. These tags sent signals that showed where the sharks traveled and how deep they swam. For months or years, everything looked normal. Then suddenly, a signal would stop. A shark that had been moving freely vanished without warning. At first, researchers thought the tags had failed. Technology can break, batteries can be off, but patterns began to form. Multiple sharks disappeared in the same areas. Some left regions they had used for years and never returned. The ocean, once predictable, began to feel uncertain. These vanishing acts became a cold case in marine biology. There were no bodies, no signs of struggle, just silence. The kings of the sea were slipping away, and no one knew why. The mystery made the great white seem even more powerful, yet strangely vulnerable. How could such a perfect predator simply disappear? How could an animal with such strength and skill leave no trace behind? For decades, the great white remained unmatched in the human mind. It was the final hunter, the ruler of the deep, the ocean's ultimate shadow. But beneath the surface, something was changing. And as the great white hunted seals in calm blue water, a far more frightening question began to rise. If nothing hunted the great white, then what was causing them to vanish? The first clues. The mystery truly began on a quiet shoreline in Victoria, where the ocean returned something it should not have. Early one morning, a massive great white shark lay still on the sand. It measured 4.7 meters long, longer than a small boat. and its pale body looked out of place against the gentle colors of the beach. This was not a normal sight. Great white sharks do not often wash ashore, and when they do, the reason is usually clear. This time, nothing was clear at all. Those who arrived first felt a strange mix of awe and unease. Surfers stopped in their tracks. Locals gathered at a careful distance. Scientists were called, their calm quickly turning into confusion. The shark's body was largely intact, yet something was terribly wrong. Its liver and several vital organs were gone. Not damaged, not torn apart, simply missing. The emptiness inside the shark was the most unsettling detail. The open cavity did not show the wild destruction expected from a scavenger-feeding frenzy. Instead, it looked precise, almost deliberate. For an animal so powerful to be opened so cleanly felt deeply unsettling. The beach, once peaceful, now carried a heavy silence. At first, no one knew what to think. Great white sharks are not easy victims. They are strong, fast, and well-armed. The idea that something had ended one and removed its organs challenged everything scientists believed. The ocean had always been dangerous, but this felt different. This felt like a message. Speculation spread quickly. Some suggested that another large shark might be responsible. After all, certain shark species are known to attack their kind. Others wondered if a sperm whale could have done it using sheer size and strength. These ideas floated through the air, but none truly fit. The wounds did not match known feeding patterns. The missing organs raised more questions than answers. As scientists examined the body, attention turned to what was missing rather than what remained. The liver of a great white shark is no small thing. It can make up close to a third of the shark's body weight. It is rich in energy, filled with oils that help the shark stay buoyant and strong. In the deep ocean, this liver is like a treasure chest of fuel. Removing it would require knowledge and power. This was not a random act. Whatever did this knew exactly what it wanted. Marine biologists began documenting every detail. They measured the wounds, they studied the edges, they compared the marks to known predators. Teeth marks often tell a clear story, but here, the story was blurred. The bites did not align neatly with familiar patterns. They were too clean in some places and too strategic in others. The shark's size made the case even more shocking. A predator capable of taking the life of an adult great white of this length would need exceptional strength or intelligence, or both. This realization shifted the tone of the investigation. This was no longer about a single dead shark. It was about discovering something unknown moving through familiar waters. The beach itself seemed changed by the discovery. The waves continued their gentle rhythm, but the feeling had shifted. The sea, once admired for its beauty, now carried a sense of hidden depth. People began to understand that the ocean still held secrets far beyond human control. For scientists, this carcass became the beginning of a modern investigation. It was the first strong physical clue that something extraordinary was happening beneath the surface. It pushed researchers to reconsider long-held beliefs about ocean predators. The great white, once thought nearly untouchable, now appeared vulnerable in ways no one had expected. As word spread, similar reports from other regions began to feel more important. Patterns that once seemed unrelated now demanded attention. The missing sharks, the sudden movements, the silent retreats from familiar hunting grounds. Everything pointed back to this moment on the sand. The empty space inside the shark told a story without words. It spoke of precision, of purpose, of a hunter that did not waste energy. The ocean had revealed a clue, but not the answer. This single carcass changed the direction of marine research. It forced scientists to ask harder questions and look deeper than ever before. The great white was no longer just a symbol of dominance. It had become part of a much larger mystery. As the sun set on the Victorian beach, the waves slowly erased footprints in the sand, but the questions remained, growing heavier with each passing day. Something had taken what it wanted and vanished back into the deep. And soon science begins its careful work, searching for invisible traces that could finally name the unseen hunter. Cracking the case with DNA, the mystery had reached a breaking point. The ocean had offered a clue, but it was incomplete. A great white shark lay lifeless, its most important organs gone, and the world wanted answers. Guesswork was no longer enough. This time, science had to speak. Researchers moved quickly. knowing time was their enemy. The shark's body was already beginning to break down. Salt water, sun, and bacteria were erasing evidence with every passing hour. If the truth was hidden anywhere, it was inside the wounds themselves. Carefully, scientists began their work. They swabbed the edges of the bite marks and the smooth opening where the organs had been removed. To the naked eye, there was nothing special to see. No clear teeth marks, no obvious signature. But what mattered was not visible. It was microscopic. Every animal leaves behind tiny traces of itself: skin cells, saliva, fragments too small for human eyes. These fragments carry DNA, a biological fingerprint that cannot lie. Even in harsh ocean conditions, small pieces can survive long enough to tell a story. The samples were taken to laboratories where genetic forensic work began. This process is slow and precise. Scientists must carefully separate usable genetic material from everything else. Sand, seawater, and decay all interfere. One mistake can ruin everything. Every step matters. The DNA was then sequenced, meaning it was read and compared to known genetic records. Each species has a unique pattern. When a match appears, it is unmistakable. This is how crimes are solved on land, and now it was being used to solve a mystery of the sea. As the results came together, a clear answer emerged. The DNA did not belong to another shark. It did not belong to a whale that fed by chance. It belonged to an orca, also known as an orca. The room went quiet as the meaning sank in. For years, scientists had suspected this possibility. Orcas are powerful, intelligent, and known for complex hunting strategies. They hunt in groups. They learn from one another. They pass down techniques through generations. Still, suspicion is not proof. Until now, there had been no direct genetic evidence in many regions to confirm that orcas were actively hunting great white sharks. This DNA changed everything. The wounds on the shark were no longer just strange marks. They became a message written in genetic code. The orca was no longer a shadowy theory. It was a confirmed predator. What made this discovery even more striking was how clean the attack had been. Orcas are known for targeted feeding. They do not always eat an entire animal. They take what they need. In this case, the focus was on the liver, the most energy-rich organ in the shark's body. This matched what scientists already knew about orca behavior in other parts of the world. The breakthrough felt like a moment from a sea-based investigation drama, a true CSI of the ocean. Scientists racing against decay, swabs replacing fingerprints, DNA strands standing in for eyewitnesses. The ocean had no voice, but the evidence spoke clearly. This confirmation closed one door but opened many others. If orca were hunting great white sharks here, how often was it happening? How many cases had gone unnoticed? How many sharks had disappeared without leaving a body behind? The discovery also explained earlier mysteries, tag sharks that suddenly vanished, entire regions abandoned by great whites for long periods. These behaviors now made sense. The sharks were not just wandering, they were fleeing. The ocean's balance was more complex than anyone had imagined. The great white, long seen as untouchable, was facing a predator that used intelligence instead of teeth alone. Strength combined with strategy had rewritten the rules. For marine science, this was a turning point. The food web was no longer a simple ladder with great whites at the top. It was a web of interactions shaped by learning, cooperation, and precision. Apex predators were not defined by size alone. The sweetness of this discovery came not from fear, but from understanding. Nature was revealing how deeply connected its systems truly are. Every animal, no matter how powerful, exists within a larger story. The orca had been part of that story all along, hidden in plain sight. As the data was reviewed again and again, one truth became impossible to ignore. The ocean had not changed suddenly. Humans had simply learned how to listen better. And just when the mystery seemed solved, another question rose quietly from the depths. If orca were doing this in one place, were they doing it elsewhere too? The orca technique. The ocean is often imagined as a place of wild force, where the strongest wins through speed and power alone. But what scientists began to see with orca changed that idea forever. Their method was not loud. It was not chaotic. It was calm, careful, and exact. Orca do not rush a great white shark without thought. They observe first. They move together. Each member of the pod knows its role. When the moment comes, the attack is swift, not because of rage, but because of planning. Instead of tearing the shark apart, Orca focuses on one thing: the liver. The liver of a great white shark is large and rich with energy. It is filled with oils that store enormous amounts of fuel. To an orca, this organ is worth more than the rest of the body combined. Eating the whole shark would waste time and effort. Taking the liver gives maximum reward with minimum risk. This is where the true precision appears. Documented cases show that orca can remove the liver with remarkable accuracy. The shark's body is left behind, mostly untouched. The opening is clean. There is no sign of random feeding. This is not an accident. It is a practice technique. In some cases, especially with younger great white sharks, orcas use a stunning method. They flip the shark upside down. When a shark is turned this way, its body enters a state of temporary stillness. It cannot fight. It cannot flee. Its powerful instincts fail it in this position. The moment is short, but it is enough. With the shark immobilized, the orca moves in. They access the liver quickly and efficiently. The rest is left behind, drifting quietly through the water. The ocean does not explode with violence. It simply absorbs the act and moves on. What makes this behavior even more remarkable is that it is not random. Certain orcapods have developed this technique over time. They learn from one another. Young whales watch older ones. Knowledge passes through generations, not through instinct alone, but through experience. In the Gulf of California, a well-known pod identified by researchers has shown repeated use of these methods. This pod, often referred to by scientists for its unique behavior, demonstrates how hunting strategies can become part of a group's identity. This is cultural learning in the wild. Each pod does not hunt the same way. Some focus on fish, others specialize in marine mammals. A few have learned that great white sharks, once thought untouchable, hold a valuable reward if approached with intelligence instead of force. This is what makes the discovery so unsettling and so fascinating at the same time. Orca are not simply taking advantage of an easy meal. They are choosing specific targets. They are selecting the most energy-rich part of the shark and ignoring the rest. This shows intention. It shows understanding of anatomy. It shows memory. The great white shark, built to dominate through speed and surprise, finds itself outmatched by a predator that relies on teamwork and strategy. Teeth and size matter less when intelligence leads the way. Watching this unfold through scientific records feels like witnessing a quiet revolution beneath the waves. The ocean's hierarchy is not fixed. It shifts with knowledge. It adapts with learning. There is a strange sweetness in this realization. Nature is not cruel for the sake of cruelty. It is efficient. It is balanced. Each creature plays its role with precision shaped by time. The orca does not destroy without reason. It takes only what it needs. It leaves the rest to the sea. For researchers, this behavior explains much of what once seemed impossible. The missing livers, the intact bodies, the sudden fear responses seen in tagged great white sharks. The puzzle pieces finally fit together. Yet this understanding brings new questions. If orca are this skilled, how widespread is this behavior? How many pods have learned it? And how deeply does this knowledge shape the movement of great white sharks across entire oceans? As one great white slips away from familiar waters, driven by an unseen threat, the sea grows quieter. Other confirmations around the world. What first appeared to be a single strange event slowly revealed itself as something much larger. As scientists shared findings and compared notes, similar signs began to surface in distant parts of the world. The ocean was connecting the dots long before humans did. In South Africa, researchers and observers noticed a troubling pattern. Great white sharks that once patrolled coastal waters began to disappear. Some areas that were famous for frequent sightings grew quiet. Then evidence appeared. Carcasses of great white sharks were found with the same missing organs. Once again, the liver was gone. The bodies showed signs of careful removal rather than chaos. This time, there was more than a body on the shore. Video footage captured orcas interacting with great white sharks in these waters. The images were striking. The movements were controlled. The behavior was deliberate. The sharks were not chased wildly. They were approached with purpose. This visual evidence matched what scientists had already suspected based on physical remains. Soon after, genetic testing confirmed the same truth. DNA found on shark remains pointed clearly to orcas. The mystery that once seemed local was now global. The same predator, the same method, the same outcome. Across the ocean, on the other side of the world, similar discoveries were unfolding in California. This region had long been a key area for studying great white sharks. Many individuals were tagged and tracked. Scientists knew their routines well. When sharks began leaving suddenly or vanishing altogether, concern grew. Then confirmation followed. DNA evidence from shark remains in California again identified orcas as the cause. The pattern was undeniable. Oceans apart, the same behavior appeared. Different pods, different waters, one shared strategy. The story deepened when researchers noticed that not only adult great white sharks were affected, juvenile sharks were also being targeted. These younger sharks, still learning the rhythms of the ocean, were vulnerable in a different way. Their presence in these events suggested something important. This was not a rare accident. It was pressure. By targeting both adults and juveniles, orcas were influencing the future of shark populations. Juveniles represent what comes next. Their loss changes how many sharks grow to maturity. This adds weight to the impact already felt when adults disappear. The ocean food web began to shift quietly. Where great white sharks left, other animals changed their behavior. Some prey species increased. Other predators adjusted their hunting grounds. These changes were not dramatic explosions. They were slow, steady movements, like tides reshaping a shore over time. One detail surprised scientists even more. In some documented cases, a single orca hunted sharks alone. This went against long-held beliefs. Orcas are famous for teamwork. Hunting solo, especially against a powerful shark, was once thought unlikely. Yet evidence showed that some individuals had learned to do just that. This revealed an extraordinary level of adaptability. These orcas did not rely only on strength or numbers. They relied on knowledge. They understood where to strike. They knew what to take. Whether alone or in a pod, they applied the same careful approach. What made this discovery even more striking was the similarity across regions. In South Africa, in California, different waters, different conditions, yet the same deadly efficiency appeared again and again. This was not a coincidence. It was learned behavior spreading through populations. The ocean, vast as it is, suddenly felt smaller. A tense picture emerged. Pods in one hemisphere, individuals in another, all using comparable strategies, all focusing on the same vital organ, all leaving behind the same quiet evidence. This cross-continental pattern forced scientists to rethink how predator knowledge spreads. Orcas are not bound by instinct alone. They learn, they remember, they adapt. When a successful method appears, it can move through groups like a shared secret. For great white sharks, this meant something profound. Their dominance was no longer universal. Their presence was no longer guaranteed. In some regions, they responded by leaving entirely. Tagged sharks fled hundreds of kilometers from familiar grounds, sometimes after a single encounter. Fear, it seemed, had entered the life of an apex predator. If great white sharks were changing their behavior on such a large scale, what would this mean for the ecosystems they once controlled? When the ocean loses its balance, the ocean is a place of quiet order. Every creature has a role, even when that role is unseen. For a long time, the great white shark helped keep that order steady. Its presence shaped life beneath the waves in ways most people never noticed. When that presence began to fade, the ocean responded. Great white sharks are more than hunters. They are regulators. By preying on seals and other mid-level predators, they help control population sizes. They do not need to hunt constantly to make an impact. The simple knowledge that a great white might be nearby changes how other animals behave. Seals move carefully. Smaller predators spread out. Balance is maintained through fear as much as through action. When orcas reduce the number of great white sharks in an area, that balance begins to shift. In regions where orcas have repeatedly hunted great whites, the sharks do not always fight back. Instead, they leave. Tagged sharks have shown sudden departures from traditional hunting grounds they used for years. These areas, once shaped by the quiet rule of great whites, grow empty of their presence. The change is immediate. Without great white sharks nearby, seal populations begin to grow. With fewer threats, seals spend more time feeding and less time watching the water. their numbers rise steadily. This may seem harmless at first, even positive, but nature works in layers. As seal numbers increase, they consume more fish. Small fish populations begin to shrink. This loss affects other animals that depend on the same food. What started with one missing predator now spreads outward, touching many species. This chain reaction is known as a trophic cascade. One change at the top flows downward through the entire system. The great white does not need to disappear everywhere for this to happen. Even local absence can reshape an ecosystem. The effects do not stop with animals alone. Fish declines affect fisheries. Local fishing communities begin to notice changes in catch sizes. Species once common become harder to find. This impacts livelihoods and food supplies, especially in coastal regions that depend on stable marine life. Tourism also feels the shift. Some areas are known around the world for great white shark sightings. Divers travel great distances for a chance to see one. When the sharks leave, those encounters vanish. Boats return with empty decks. The sea feels quieter, less alive. Even underwater forests are touched by this change. Kelp forests rely on balance to survive. When certain fish species decline, others may increase. Some of these animals feed on kelp or disturb its growth. Without the regulating presence of top predators, kelp forests can weaken. These forests are important shelters for many marine species. Their loss removes safe spaces and breeding grounds. The ocean does not collapse suddenly. It reshapes itself slowly. Changes creep in like a shifting tide. Many people never see the full picture, but scientists, divers, and fishermen begin to notice patterns. Seals appear more often. Fish schools thin out. Great white sharks are no longer seen where they once ruled. This reshuffle is silent, but it is powerful. The role of orcas in this process is complex. Orcas are not destroying the ocean, they are acting within their nature, but their influence reaches far beyond a single hunt. By changing where great whites live and hunt, they indirectly reshape entire ecosystems. If the loss of one apex predator can reshape entire ecosystems, what does this mean for the future of ocean life itself? The terrifying new reality. For decades, great white sharks were seen as untouchable rulers of the ocean. Their speed, power, and precision made them apex predators, feared and admired. Humans marveled at their dominance, and even other marine animals gave them space. It was easy to believe that nothing could challenge them. That belief is now being rewritten. The discovery that orcas actively hunt great white sharks sent shockwaves through the scientific world. Suddenly, the untouchable became vulnerable. Marine biologists had to reconsider everything they thought they knew about predator hierarchy. The ocean was no longer a simple ladder of power with a single ruler at the top. Intelligence, strategy, and precision could rival sheer size and strength. Even the mightiest predator had enemies lurking in the shadows. This revelation carries a weighty emotional impact. For researchers who have spent decades studying great whites, it is unsettling to see these creatures, symbols of fear and power, forced to flee from stealthy, calculating hunters. Observing tagged sharks abandon traditional hunting grounds or respond to the presence of orcas highlights a vulnerability once considered unimaginable. Apex predators, it turns out, are not untouchable after all. The implications extend far beyond curiosity. Great white populations are already under pressure from human activity. Fishing, habitat loss, and accidental bycatch threaten their survival. Now, natural predation adds another layer of challenge. Orcas, acting within their instinct and intelligence, increase the pressure on a species struggling to maintain its numbers. Conservation efforts must consider this dynamic, balancing human impact with natural ecological processes. The ocean's hierarchy is changing, quietly but profoundly. What was once considered safe and immutable is now fluid. Even the most powerful must navigate danger. Even rulers must be vigilant. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.